start streaming.
I'm gonna record this just to have a backup. All right, so we're gonna let the streams be connected, and then I'll.
We are live on YouTube.
Woo! All right, welcome everybody to our first virtual SFNode. We're all sheltering in place. I made us some wonderful Trader Joe's frozen pizza. It is now officially cold, so it has full meetup vibes. I raise a glass to all. Cheers. So, this is a bit of an experiment, though we will probably do this again. I have very little hope for, us being clear by May. So we'll probably do this at least once more. This may become a solution if we like it. January is always weird in figuring out whether we get back together or December, now that we've moved to the second Thursday of the month. We're hitting mid-December, so we might do this again. And it's fantastic to get folks who are able to join us from around the world. Hopefully it'll be a good experience for everybody. Where's the back channel? Where's the back of the room? Are we DMing? Where?
The SFNode team can use our Slack, or we probably can do.
That's really exclusionary.
Well, but we can also do either hashtag SFNode on Twitter. We can have folks monitoring that.
That'd be fun.
For folks in the Zoom, we can utilize the chat.
Right. Yeah, there's Zoom chat. There's also YouTube live stream chat notes.
That'd be fun.
As you can tell, this is a well-oiled machine, right?
That's right. We've done this millions of times. But so the link for YouTube is here.
Yep, we just tweeted that out.
So this is I guess inside of Zoom. This is kind of the back of the room, and then public comments go out in the YouTube feed. So that'll be fun. Welcome to SFNode. So Winston, we have a list of things. Before we get into some of the overview and stuff like that, I want to give a bit of a call out for a call for speakers. Especially folks interested in doing. We have at least another month of virtual meetups. It'd be great if we could bring some new faces on. SFNode is a community meetup here in San Francisco, California. Each month we try to bring together a variety of talks ranging from beginner to advanced, and it's really an opportunity for community members, Node.js community members, and adjacent communities to practice their talks, to share what they've been working on. We try to make it a really sort of open door for anyone who has something to share. I've been in developer relations for years. So, Debrels, please, yes, come, tell the story, don't sell the thing. Beyond that, we'd love to have you come and speak. So, Winston, do you have your deck ready? Do you want to either throw that up and I'll speak to it, or you're welcome to go through our community overview?
Should be in the our chat.
Pull it up. I have it here. Okay. the screen share thing. Okay. So, oh, you know what we should add? Sorry. JSLA, has a third Thursday. It would have been nice to add. Now that we're all virtual and at home and looking for a thing to do. So, we're one of quite a number of meetups and a whole family of folks around Node.js and JavaScript. Specifically Waffle.js. It was a great event. A couple days ago, and they'll have their next event on the 6th. Go buy a ticket and support the folks there, and then we'll be back on the 14th of May. Probably still at home, maybe at a business near you, and keep an eye out. I'll try to retweet on the SFNode Twitter account, twitter.com SFNode, JSLA. They did a really, speaking of well executed production. They had everything set up on Twitch and the speaker on a thing. It was good. Very very inspiring. Code of conduct. We follow the JSConf code of conduct. Please be respectful. That includes your interactions on YouTube, here in Zoom. As we're going through the talks, please raise your hand, and we'll try to have one of the organizers interrupt the speakers rather than everyone jumping on and piling on. Please reach out to us if anyone is DMing or acting untowards, and we'll ban them forever. And like I said, great time to submit a talk. Our talk submission process is really simple. If you have an idea and you want to share it with us, feel free to just go into GitHub, create an issue, and walk you through it there. If you want to get feedback, our email is team@sfnode@gmail, and we're happy to walk you through that. Preference, the easiest and most sort of well-tooled process that we have is GitHub. So happy path, as long as you're comfortable. Even if it's a no, send it to GitHub. And then of course we're SFNode on Twitter and YouTube. And this is being live simulcast to our YouTube channel. So that's exciting first, I believe. All right, so we have two speakers tonight. Let me get off of sharing and back to my notes. Very smooth, very graceful. So we have two speakers tonight. Thomas Hunter is going to share Friends Don't Let Friends Cluster, and dive into one of my favorite topics, hating on the cluster modules in Node.js. And then our own Chris Euler is going to give a talk. Nope. I'm getting signal. We're shutting it
Not
down.
This guy.
No.
Different Chris.
Oh, Chris Upperwall. Fuck. Chris, sorry. Other Chris. Another Chris that I love. Sorry, Chris. Is Chris on?
I don't see him yet.
We may get another talk from Chris Upperwall, who has said that he would be available, but he's not on yet. So we may get Chris Euler yet. 30 minutes of dad jokes.
I'll start practicing my type 5.
Speaking of dad jokes, do you want to warm us up with a dad joke? Do you have anything in the virtual pocket?
Did you guys think you were going to get away without one? Like,
No.
just because it's Zoom now, you think there's no dad joke? I actually do want to point out a couple of things. First off, you can tell the people who are sitting at their desk that they usually use for PC gaming at home based on the headsets that they have on. looking at you, Thomas and Addison and Joe and Winston probably too. I left mine on the desk because they're just too damn big and clunky. Second, I don't know if anybody noticed, but Paul Grock was in here for a bit. Where the hell did he go?
Where'd he go?
Like,
He talked me into going up and visiting him on the farm and doing like worky work when this is all over. So that sounds really good right now.
yeah, right. Just go stick your hands in some dirt.
Right.
Yeah, I don't know what happened to him, but he was here. I swear I saw him. But yeah, come back to us, Paul. Peachy rock. Okay, and Rich, keeping it real in here. So yeah, for those of you who have never attended an in-person SFNode, my name is Chris. I'm one of the co-organizers, and typically I do this in person, and I don't use a microphone, so I'm very loud. My girlfriend is giving me hell for it right now too.
Confirming the loud.
yeah, you know, per usual. But I always like to start the meet off with a little bit of story time. And the story today is actually very relevant because I think that in the current situation in the world right now, a lot of people are stressed, and it's a lot of weight on everybody's, you know, mind, and it's a lot of anxiety. So my girlfriend was actually stressed the other day, as have we all been. So I drew her a nice hot bath. You know, you could see like the steam tendrils coming up, but she didn't like it very much, so she just crumpled it up and threw it in the trash. Like, yeah. See, it's better in person when I can actually hear people groaning. The groans are so much better. With Zoom, everybody's on mute all the time.
We'll figure out how to add a soundboard for next time, and we'll get a crowd of boos.
Oh my god, yeah! I need the Price is Right, you know, bust out music. Bum, bum, bum.
Awesome. Well, now now we're primed and ready. I couldn't hear the peanut gallery.
No, that was my girlfriend actually laughing at my terrible joke because she decided that she was going to make a follow-up joke to it.
Oh, thank you. All right. Well, Thomas, if you're ready, I think we can go ahead and get started. It looks like we're light duty on schedule, so please don't feel like you need to cut for time.
Sounds good. I know that Fernando usually has about 30 talks prepared, so maybe we'll drag him into this.
Let's do it.
Can you see my slide?
Yes.
Great. Cool. All right. So without further ado, here we go. So the name of this talk is Friends Don't Let Friends Cluster. Of course, I'm Thomas Hunter. And the content of this talk is based on an upcoming book of mine called Distributed Node. That should be published through O'Reilly early 2021, hopefully. So funny story about this. Actually forwarded a early copy of this to Dan. I was like, hey, Dan, would you like to maybe work on a forward for this? And he reads through it and he's like, oh, I see you mentioned cluster. He's like, it sucks, right? I'm like, yeah, it's not the best. And he's like, you hate it too, right? I'm like, yeah, I hate it too. And he's like, prove it, give a talk. And so here I am giving a talk on cluster and why it's Anti-pattern. Cool. All right, so here's the situation. This might be familiar to most of us. You know, you're building web servers. I'm sure most of us have done that. But this problem, you know, we find out that one process just isn't enough. And so reasons why one process might not be enough. Well, a single process, of course, can get overwhelmed. I'm talking about a node process here, of course. CPU intensive work, you know, that can block the event loop, slow down your process. Perhaps a particular process has really high memory requirements. It needs to be spread out across multiple machines. Or of course, you know, any given node process can crash. And so if your one single process dies, then, well, there goes your application. Your users are no longer able to use it. So the solution to this might sound obvious, might not, but it's to run more than one process. And so we'll refer to this as horizontal scaling. And so in theory, two processes are able to handle twice the load as one process, though that's not always true. And then in this case, if one of these processes were to crash, then another one could survive. And so your application may then still be able to run and serve the requests of your users. So you might be wondering, okay, what sort of tools are available to allow me to run multiple processes? I'm glad you asked. So let's take a look at something called cluster. Cluster makes scaling easy. I'll just put that out there. And so here's some example code. So this example code, this is basically taken from the Node documentation for the cluster module. I took their big examples and then distilled it down to a shorter one. And then I threw in this little lucky number bit. So in this case, we have a single file. This single file is requiring a cluster module. It's also requiring the HTTP module. And then we're declaring a variable called lucky number. And that's just the result of math.random. Then we have an if statement. So we're checking to see if cluster.master is true. If so, we're going to print that we're in the master, and we're going to call cluster.fork 2 times. Now this is a shorter version of the node docs, and the node docs actually counts the number of cores that you have and then forks accordingly. But in this case, we're just assuming 2 CPUs. Otherwise, if we're not the master, what we're going to do is we're going to create a server. Any request that comes in, we're just going to respond with a 200 and then send the message hello world as well as our lucky number. And we're going to listen on port 3000 and then print that the worker started. But the problem is that a cluster perhaps makes scaling a little too easy. So, you know, looking at the example in the documentation, sort of looks like there's perhaps a single global variable. You know, looking at the code, we have to wonder, is that lucky number variable, is that shared? Does the master process have to use the HTTP module? What does it mean by master process? How does this thing actually work? So here's a bit of a clear example. I think this one makes it a bit more obvious what's going on. So in this case, we've split our example into 2 files. Previously, it was just a single unnamed file, but now we've got 2 files. The first one's master.js, and the second is worker.js. In this case, the master file loads the cluster module. Again, it's going to print the message that it's running. And really, the only major difference in this example is that we're now calling this cluster.setup master method. So that allows us to provide a configuration object to configure how the cluster works. So in this case, we're passing an argument called exec, and we're setting it to the path of this worker.js file. And then again, we call cluster.fork 2 times. So in this example, the master.js file, that is the entry point into the application. You know, that is what you're actually going to run with Node. Now within the worker.js file, again, we're declaring this lucky number. Again, we're requiring the HTTP module, creating a simple listener, listening on a port, and printing a message. So in this case, you can see that the HTTP module is not required in the master and that the cluster module is not required in the worker. But ultimately, the application ends up running the same way. So cluster, it works by using n+1 node processes. So if in this example, we have 2 workers that we want to spread the load out amongst, we end up actually having a 3rd process. And that 3rd process is the cluster master. And so the way cluster works is that the master will spawn different child processes. And so by default, it actually says, hey, run the current file multiple times. But then when we pass in that exec argument, we're actually able to say, hey, hey, execute this other file instead. So the master process, it spawns these worker processes, and then it sets up an inter-process communication, IPC, channel between the master and the workers. And then that's actually how the master is able to communicate to the workers. So in this case, when the workers are saying, hey, I want to listen on port 3000, it's actually passing a message to the master, and the master ends up listening on port 3000 on behalf of the workers. And then any requests that come into the master are then passed to the appropriate cluster workers. And then requests entering the master in this manner are distributed in a round robin style amongst the different workers. And by round robin, I mean the first request will go to cluster worker 1, the second goes to worker 2, the third goes to worker 1, and so on, back and forth. One interesting note here is that if one of the workers says, hey, I want to listen on port 0, that's node parlance for saying, hey, give me a random high port and listen on that. So in the case that multiple cluster workers do listen on port 0, the master will choose a single port on behalf of them and then forward requests to the different workers. And so you could actually recreate this functionality by using child process, setting up these IPC channels, listening for requests, and passing messages to and from the workers from the master. And so as you can probably guess from the title of this presentation, cluster is going to have a few shortcomings. The biggest one, in my opinion, is that both the master and the worker processes need to run on the same machine. So this means you're still left with the same memory and CPU contention. So you're still stuck on that same box. You may have other machines running, but with cluster, you're stuck on just the one box. Also, as I mentioned, it requires 3 node instances instead of just 2. And in practice, what I've seen in code bases is that a lot of applications end up loading all the same modules within the node master process that they do in the clusters. So based on that documentation example, we sort of saw everything in a single file. So within that single file, perhaps you're loading your Express server, perhaps you're instantiating some database clients. Perhaps each one of these processes is pooling connections to a database server. So if you have 3 node applications running and each one of them are loading those same database singletons, perhaps instead of having 20 connections to your database, you actually have 30 running. So, it can result in not only wasted CPU, wasted database connections, but wasted memory as well. And then, if there is a bug in your application, which perhaps the database goes offline and comes back online, not only would that kill your workers, but it would kill the master as well. Another shortcoming is that cluster works by performing layer 4 routing. That just means that it routes at like the TCP layer. So it's not going to properly route long-lived requests. So since it operates on this L4 TCP layer, it's actually a bit unaware of the concept of messages at a higher level. So as an example of this, consider the gRPC protocol, which is a way of sending remote procedure calls over HTTP2. And so if you have a node master process running, you're using the cluster module, and then a client connects to the master and establishes an HTTP2 connection to send gRPC messages, the master will end up picking one of the workers to receive the requests, to receive these gRPC calls for that particular client. And unfortunately, with this approach, since the master is unaware of when a message essentially terminates, it can't really tell when one message ends and next begins, all those messages will get sent to the same backend service, which means that your load won't get properly distributed amongst your workers. All right, so now we've covered cluster, let's look at this thing called the reverse proxy. So reverse proxy is able to do a few things. For example, it takes a request that comes in and it proxies it to a backend service. As you can see in the diagram, that's how it works. That's essentially the basics of what reverse proxy does. So in this case, the green process that represents our node application, the blue process that represents our reverse proxy, and then you can see the request coming in. It's also able to conditionally route requests to different backends. And so, for example, it can look at a message coming in, look at different pieces of it, for example, maybe the path or like a session cookie, and it's able to route that request to a different backend service. So for example, if you've done any work with like AWS's API gateway, or tools similar to that, you're able to say, hey, this particular set of paths will go to this service, and this other set of paths will go to this other service. That's like a way to build up an API facade. Another thing that reverse proxies can do is they can perform the encoding duties on behalf of your application. So this includes TLS termination, gzip compression, things like that. It's also the ability to sanitize requests. And so you can get a malformed HTTP request. Perhaps somebody discovers a new zero-day vulnerability in like the Express parser, or I guess the Node HTTP parser. So, well, actually the reverse proxy would be able to get that request and either clean it up before sending it to a backend service, or just drop the request entirely. It's also able to implement sticky sessions, which is a way to force a particular client to keep communicating with a particular backend service. It can even modify headers, drop headers, add headers, stuff like that. Now, HAProxy is an example of one of these reverse proxies, and it's the one I'm going to cover in the rest of this presentation. Much like Cluster, HAProxy performs routing based on the round-robin algorithm as well. That can be overwritten, much like actually with Cluster, you can specify a routing algorithm as well, but it defaults to round-robin. One thing that I like is that the configuration is declarative. So if you're using Cluster, you're configuring it by writing a whole bunch of code. And then of course, code can have bugs, but if you're writing something that's declarative, I think it's safe to say that the odds of something being declarative is usually a little less likely to be buggy than its imperative equivalent. HAProxy is actually pretty efficient, uses an event loop. It's attempting to do as much of the processing as possible within the kernel instead of user land. The memory, the rate at which memory grows and shrinks is usually a lot less than the rate at which memory grows or shrinks within a Node application. And then on my Linux machine, the HAProxy is about a 13 megabyte binary. And it's so small and efficient because it's ultimately written in C. So let's look at some configuration. So here's an HAProxy configuration file. So what this configuration file is doing is it's taking incoming requests and then it's routing them to two different backends. And so this configuration file is broken into 3 different sections. The first one here is called defaults, and that's a way to configure the other sections. In this case, we're saying that the mode is HTTP. And so what that's saying is that, hey, HAProxy, the messages you're going to be receiving, these are HTTP. Let's inspect these messages and look at them at the L7, the layer 7 layer, instead of just a TCP L4 layer. And so that gives HAProxy the ability to make routing decisions based on things like paths and headers, things they wouldn't be able to do if it was treating a message just as plain TCP. So the next configuration section, that's how we configure a front end. And so in HAProxy parlance, front end is something that listens for requests. In this case, we're saying, hey, bind on the local machine, the local interface using port 3000. And it's also saying that it's going to dispatch these requests to the web API backend using that default backend declaration. The final section is where we actually declare this web API backend. And so in this section, we're saying, hey, there are 2 servers. Each one of these servers has their own unique name. And here are the hosts and ports that this service is available at. In this case, both the backend services are running on localhost, but you could actually use any host name or IP address that you wanted. So for example, you could host these on a separate machine. In this case, what we're saying is that incoming requests to port 3000 are being sent to ports 3001 and 3002 on the current machine. And so here's a diagram of what that configuration would look like. Much like the diagram we had with the cluster architecture here, again, we see that a request goes in, a process is running, it's listening on port 3000, and then it's dispatching requests to other processes. But in this case, instead of using IPC, the dispatched messages will actually end up being HTTP messages as well. In this case, the requests are sent to two different node processes. Each of these are listening on a different port, one on 3001 and one on 3002. So why might you want to prefer HAProxy or really any other reverse proxy over cluster? Well, most importantly, you're able to route requests between two different machines. So there goes your memory and CPU limitation. It also leads to a smaller resource footprint. So previously we'd run 3 node applications and who knows how many modules those are loading. Instead, we're going to load just 2 instances and the HAProxy binary. Something that I really like is that we get to offload complexity to code that we don't actually maintain. And so, by code we don't maintain, I'm not really referring to the configuration file, but instead, the code that goes into making HAProxy run. And so in general, with this approach, it's going to be a bit harder to crash HAProxy than it would be to crash a node application. You're probably not ever going to encounter any runtime errors with HAProxy, unlike you would, at least in code that I write for node applications. It also simplifies the application. So if you're using HAProxy, you don't necessarily have to perform gzip compression. You could do that in HAProxy. You also don't have to perform TLS termination. You don't have to load certificates. You don't have to manage cycling them as they expire. All that complexity you're able to pull out of your application. And so, maybe the complexity doesn't look that much within your application. So, perhaps you're introducing these features by way of, installing a module and requiring it as a middleware. But really, it does mean that there are more moving parts within your application. When you do load all these modules, it is more memory that's being used. And the more moving parts just means more places where an application can fail. And HAProxy happens to be both layer 4 and layer 7 aware. And so you can actually configure it to do things like, be aware of these gRPC messages and dispatch them to different workers. All right, so now it's time for some exciting graphs. Let's compare some performance. And so what I'm going to do in this section is compare what it means to perform these encoding operations inside of HAProxy versus inside of the node application. So in each one of these cases, HAProxy is going to sit in front of the node service, even though HAProxy might be doing nothing other than being a simple pass-through. The reason I'm doing that is because by introducing HAProxy, we do naturally introduce some latency as there's going to be an additional network hop. So these tests only test encoding within or without the node application. Another caveat with these tests is that instead of just loading the HTTP, HTTPS, and gzip modules, I'm actually going to load like a real framework. This framework is going to do routing, just a single route, but there is a routing layer involved. And the message payloads, they do have JSON that gets parsed. So it's not just a really simple example like earlier in the slides, where it was just a very simple listener using the HTTP module. And also with these tests, you can see the versions of the software that I'm using at the bottom. So this is using Node 13.6, HAProxy 2.1, Fastify 2.12, and Fastify Compress 2.01. And there's also the bit.ly URL at the bottom of these slides that'll take you to the repository. You can actually run these benchmarks yourself if you don't trust me. All right, so in the first case, we're going to benchmark what it means to use TLS termination or to perform TLS termination within HAProxy versus within Node. So in each one of these graphs, bigger is better. And each one of these graphs is measuring throughput. And so for performing these tests, each one of these tests is using autocannon. And so autocannon will send a bunch of requests to your server and then break them down into different percentiles. So the first blue line says, hey, this is the slowest 1 percentile. The red is slowest 2.5%. Yellow is slowest half. Green is the slowest 97.5%. The average is orange. And the minimum value that encountered is that teal at the bottom. So in this case, we see that if, assuming the node service is returning a 17 kilobyte payload, we see that HAProxy has a 13% higher throughput rate than the Node.js when HAProxy performs the TLS termination. Now, if we crank that 17 kilobyte payload up to 170 kilobytes, you see that HAProxy does pull ahead a little bit, and it jumps up to about 18% higher throughput. So really not that interesting. In the case of TLS termination, I would say it's much more interesting that we're able to pull the certificate management outside of the Node application and do that within an external process. The next part is going to be a bit more interesting with gzip. So if we perform gzip compression within HAProxy instead of within Node, assuming a 17 kilobyte payload, I'm seeing that HAProxy is about 600% higher throughput than Node. And then if we change that throughput rate, or if we change the payload size to 170 kilobyte, you see that HAProxy, it slows down a little bit. And you see HAProxy is only 400% higher throughput than in Node. All right, well, that's the presentation. Feel free to follow me on Twitter. If you want to view these slides, you can either take a screenshot, I guess, since the address has been at the top of the screen the whole time, or hit that bit.ly URL, or hit that other bit.ly URL to actually see the benchmark repository. And again, this content is based on my upcoming book, Distributed Node.
Forward by D-Show.
Exactly. Hopefully.
Great. So, question. What's the most number of clusters you run in production?
Most number
of
cluster instances using the Node cluster module?
Mm-hmm.
2.
2, okay.
Yep, never really used it much. 2 employers ago, one of the teams would actually load cluster within every single one of their Docker instances.
What?
Yeah, it was kind of weird. I don't quite know why.
Early on, cluster predates Docker, right? And so, early on, there was pressure from folks, looking at, all right, we got all these systems that do parallelism. Node is dumb. What are you going to do? And, cluster is kind of the rough answer for that. I didn't do this personally, but part of the depth of my hatred for cluster comes from a team. They were somewhere in Europe, but they explained to me that their node process was slowing down because they had cluster configured with 30 children hanging off of it. To maximize their CPU, and basically the IBC on the main instance was just getting bogged down with all of the JSON serialization back and forth to all the processes, and it was a mess.
Yikes. Yeah, I will say I think at the time cluster was probably the best solution for concurrency Node. Sort of that code example does look pretty magical. It's like, oh, drop in this thing, and essentially, your web application, boom, suddenly running on two machines instead of one.
Right.
And yeah, I definitely mentioned the caveat. Theoretically, 2 processes are twice as fast as 1. Yeah, as you mentioned, there's you still have to get those messages through a single point, and then so in the case of cluster, you deal a lot with message serialization, deserialization, which doesn't lead to a doubling the throughput for doubling the process.
Yeah, and subsequently we've gotten much better tools for having a single instance kind of workflows with Docker on kind of a more robust end, and Lambda approaches as an alternative. You just want to fire through an instance path.
Yeah, yep, definitely. The ecosystem has evolved since then.
Awesome.
I'm not gonna lie. I
furthers?
still love using cluster module for doing like one-off scripts. It's great.
I'm just gonna mute Chris. No.
Dad jokes.
Hey, it was funnier than the last one.
Anyone else have questions? You can use the hand raise thing if that helps.
Yeah, I'm sure by now everyone is a professional at Zoom, considering most people are probably using it 10 hours a day.
Oh, I have a quick question. If you had like multiple like services, would you put HAProxy in front of like each kind of service type, or just like have it be on the edge and then kind of set up like multiple, you set up like multiple backends in like a single HAProxy?
Yeah, so I think if I had, I guess a heterogeneous set of backend services, but perhaps a homogeneous group of scaling an individual process. In that case, I might set up a hierarchy of HAProxy instances. So you could have one HAProxy instance per cluster of related services, but then you could have, so maybe have like 3 different applications, a profile view, gallery view, account setup view. And then you could have a single HAProxy in front of that. So I just can't see my hands. I don't like doing the hand stuff. You could have I got Endor behind me, but then you could have a single HAProxy in front of those 3 other HAProxys, which then does routing based on the path.
Okay, cool. Yeah, sounds pretty interesting. Actually, have you found like as opposed to cluster, like the infrastructure kind of maintenance, like to be more or less difficult? Like do you have to like rely on like kind of an ops person now for that, or has it been kind of like batteries included?
Batteries included might not go that far. I would say it's easier to manage putting certificates, dealing with certificates with HAProxy as opposed to doing it within your Node applications. There's other things that's nice to standardize at a company, which I think is easier to do by perhaps sharing HAProxy configuration instead of expecting everybody load the same Node modules, or for example, like configuring Cypher suites. I think that's a bit easier to configure using standardizing on different teams within an organization. I think that's easier to do with HAProxy than with just doing it in a Node application.
Yeah, I would say that at early stage, if you don't have a lot of traffic, cluster's going to do fine, right? But if you're going to ramp, and you don't have a lot of ops folks, and it's just a bunch of programmers, HA is definitely approachable. So declarative syntax, kind of stupid proof, and does what it says it does out of the box. So yeah, it's gonna be more work. You probably want to ship it in V1, just with cluster. But if you're gonna ramp, especially to multiple machines, farther on down the line, the investment into something like HAProxy or a dedicated proxy solution, it's going to pay off.
Yeah, it's kind of easy to like forget about stuff outside of Node.
Right. It's a Swiss Army toolbox. You can do anything and everything with it. But sometimes should you? And then some of these legacy bits where they were created, they're useful at a certain level of scale, but really beyond my opinion, beyond the sort of proof of concept or handling the hundreds of requests a day, kind of a thing, plugging along. You want to go with something that really does it. And Thomas's charts on the throughput that you're going to get with HA versus Node, tell the entire story. it's there. Like it's a dedicated service that does just that, and isn't bogged down with trying to do anything else.
Right. Cool.
Hey, Thomas, one thing I see usually newcomers and folks maybe transitioning from another language into Node run across is PM2. And I'd love to hear kind of your thoughts around that, because I know, especially for beginners, PM2 often sounds like the robust version of cluster.
I've honestly not used it enough that I wouldn't feel comfortable talking smack about it, I guess. I'm sure Dan has something to say though, so somebody else in this talk I bet could definitely speak better about PM2. It looks cool.
Oh God! Oh no! Don't get me started on PM2. I like yeah. PM2 at this point, run away. It is marginally better than cluster if you have nothing, but really go to HAProxy, go to a proxy rather than PM2. As I was saying, with the not much scale level, just stick with cluster. If you need to plan for scale, basically you're going to go from where you are to the next level. Invest a little bit of effort into learning a proxy, and they're dedicated services that do a good job of what they do. So Addison, you have your hand raised. Please feel free.
Thanks. I just had a quick question. Like, do you ever see that something about your infrastructure? So in this case, you might want to use both HAProxy on like your front end, and then maybe use the cluster module to optimize for a certain, I don't know, you have like a quad core machine under the hood, so you'll use cluster under there.
Yeah, I guess usually I work in situations where, let me think. So I've worked at companies that use like Mesos, Apache Mesos, and Kubernetes. And so these are tools for easily deploying, scaling up, scaling down Docker containers that contain a Node application. And then, each one of these, the modern unit of application deployment is like a self-contained service that receives requests, listens on a port, and then makes outgoing requests. And so in all these situations, sort of the concept of how many cores is on the machine, that's all like hidden from you. It's like an abstracted detail. So using things like cluster, you really just don't need to think about. Instead, you really just think, hey, let me listen on this port, do stuff as fast as I can, and then be done. And then so really everything, all that other stuff, like how many instances to run, that's all like these ephemeral details that really should exist outside the application. But the problem with cluster really is that it's something that exists within the application. And so, really, I don't think there's, with these the modern deployment patterns that we get, I don't think there's really too much need to use cluster. As Dan mentioned earlier, though, maybe at a smaller shop, if you don't have these tools at your disposal, it does make things easier, certainly. But, after a certain point, you get to the point where you wouldn't really want to use cluster.
Yeah, container or Lambda, those are your primitives. The level of compute, use that as your instance, your isolation, rather than trying to maximize Node. Node excels as a single event loop doing. Did my shiitake log come in? Okay, sorry. I ordered a shiitake log, and I heard the mail come in. Yes.
You do have to explain exactly what a shiitake log is now.
So shiitake log is a log that has been inoculated with shiitake mushroom spores, and it goes in the garden and it will produce shiitake mushrooms.
Ooh.
Yeah.
Okay.
Ooh.
That it is exactly what it sounds like. That
It's
is
exactly what it
fantastic.
sounds like. I'm very bored.
You keep that on like the kitchen table or in the window?
No. I've got fairly evolved garden now up on the roof. So we have a rooftop deck, and we've got a bunch of containers up there. Started with one lemon tree, just over a year ago, and it's continued from there to be quite an involved thing.
Man, and here I was feeling good about regrowing my scallions.
There you go. All right. So up next, I will drop into the chat. Once I get done introing our next talk, a link to my shiitake log that Ian Coldwater recommended. Joining us tonight, we have not Chris Euler. Chris, I sort of tuned into it was a Chris and didn't know which one, so I threw Chris Euler under the bus. It was like Chris is giving a talk. But Chris Overwall, who worked with me at PayPal, is going to share a talk on asyncwait.
Yep.
Awesome.
Let me share my screen. Let's see, desktop one. Oh no, I have to allow Zoom. Extra features. 1 second. Oh my God. Okay. And here we go. Can you see my screen?
Yes.
Cool. All right. Oh, oops. All good? Okay. Cool. All right. So, oops, I spoiled the surprise. Okay. So this talk is basically like demystifying asyncwait and kind of going into how exactly you can build it using kind of like language constructs that existed before like ES 2017. And so I'll get into what those are in a little bit, but the joke was like the musical, just kidding, I would never subject you to that horror. So I'm Chris. I work as a software engineer at yeah, this is a picture of me from college where I was doing homework and I had a cat just hanging out in my hood. I really like JavaScript things a lot. An old coworker at PayPal told me one time that I've never heard someone get so excited about JavaScript before. And I feel like that just kind of describes me as a person. Basically moving on with it, like, what's the asyncwait? I mean, hopefully everyone's gotten a chance to kind of use this. Basically, it was in ES 2017. There we go. A language feature that basically makes asynchronous programming easier, mostly through like finally getting that like top-down synchronous readability that like we're kind of there with like promises and like not quite there with callbacks. And so basically you can effectively pause execution and wait for something like a fetch call to happen without actually like blocking the event loop or like stopping the program. And yeah, basically like the way execution flows is a lot closer to how the actual like code reads now. So yeah, it was introduced in ES 2017. Most modern browsers support it now. So people do it's like differential builds or something where you have like your Chrome like -2 version build where you don't have to like include like regenerator and like a lot of Babel features. So you can use this natively in like, I think most browsers now. Everything Node 8 and above supports it. I think if you're using Node 8, you have some problems because that's end of life. So basically it shouldn't be like that fancy or new of a feature now, but just as kind of like a walkthrough history, this is kind of like a function to basically make a payment for a user and maybe notify them about their payment. And so in callback land, basically you need to have this, this next kind of argument to your function. And every time you call like a service, basically you need to make sure you have your, your callback to basically say when this is done, just call this function using kind of the node style of error and like data. And you have to make sure, if there's an error, pass that to your next function. Otherwise, kind of do your next thing. You kind of generate this little pyramid of death, which was a meme for so long. But some other things that are a little bit kind of interesting is, for example, like the callback in profile serve requests, like there's not really a guarantee that function won't get run multiple times. I mean, maybe you can memoize it to kind of guard against that if you're just kind of passing this to a library, but you don't really know. And then if you forget to propagate the error, that error just kind of gets dropped. So you won't really know about it in like kind of your future code or the code that runs next. So basically, like kind of things got better with promises. Kind of, you get a little bit more of this kind of top down, like first you do this kind of like chain thing of then you do this thing, then you do this thing. You still kind of have these these function callbacks kind of, running kind of not now in the function, they're running later sometime. But you get some benefits where, like when a promise is done, it's like immutable. You can't kind of like, you can add as many thens on it as you want to, and you're not going to run this thing. Like you're not going to make 5 payments accidentally. So, it's a little bit nice. You can return this. So you kind of invert the control from passing in your next thing to do to getting a handle back that you can then kind of hook up things to. Same with error catching too. Basically errors propagate up so you can kind of catch them when you want to. So yeah, life with the wait. This could be, especially if you're coming from like Python or something where you're like, I just make, requests.get and it waits and then I have the data. There's no like .then or callbacks or anything. So it's, top down, kind of a lot nicer. You can still interact with it through like a promise interface in this make a payment and stuff call at the bottom. So pretty cool. I mostly explain that through this, but basically functions, they can be anonymous or declarations. You just need that async keyword. They always return promises. And so you can kind of act like as if they were just regular functions that return promises. So they work really well with like existing libraries that aren't using async necessarily. Something really nice is this kind of, in this get guides function, you can kind of sequentially make network requests. So you can just use like a regular for loop, basically to say, do this thing, wait for it, and then once you're done, advance to the next one. This example is kind of contrived because we don't really need to wait for it, but just kind of to get the point across. But yeah, so like, if you're still like promises are cool and async seems new and weird, most of this I went over in that example, but they invert kind of the control, immutable, error propagation, all that stuff. Promises can be kind of weird though. If you break the chain or don't return it back from a function, you kind of lose that handle on things. You can't really wait for it anymore. Depending on your environment, if you don't catch the error, you might not catch it at all. And I think the biggest one, you still have to reason between code that happens now versus code that happens later. Mostly like in this example, I'm sure everyone's done this like at least once, but you kind of have like this scope that's happening in the current execution, and maybe you kind of forget that like actually this promise callback doesn't really happen in that same kind of vein, and so you return like undefined for birthday. You kind of still have to think about like, is this like a now thing or a later thing? Also, if you want to do sequential things, sometimes you can do like this crazy reduce thing as opposed to this for loop thing in the bottom. If you're really into functional programming though, like maybe that's your thing. No judging. But this is kind of how I feel when I have to do that. It's basically just like sadness and despair on a beach. But yeah, some of the extra patterns, you don't have to await everything when you do it. Like party profile res and account res, those can all be promises, and you can kind of wait to realize them into their kind of eventual thing. Same with try catch. You can finally use try catch for async things. You just have to make sure you await it. Otherwise, the function will just blow straight through and not actually kind of wait for that to happen and throw the error in that context. This is a really bad joke, but so what do magnets and asyncwait have in common? The insane clown posse probably don't know how they work. I'm so sorry. But anyways, basically, if we wanted to make this using existing things, we basically need resumable functions. And if there's one thing I know about JavaScript, once you like start a function, even if you like schedule callbacks for later, like that function is going to run until it's done. Like you can't be like preempted or stuff like that. Not like that weird kind of parallel multi-thread type thing. Unless we got generators and promises, mostly generators. That's like the big key here. Basically, just super quick generator kind of intro. I don't really see these too much in Node. I see them a lot in Python really, but basically it's a function that can like be paused midway through execution and return values back, and then be restarted. The super contrived example is range, where you can just say like, create a list of like 10 million things, and you won't run out of memory because you're really just kind of replacing that list with like a computation instead. But something that's kind of cool about generators is you can actually, instead of just passing back things from a yield, you can pass things into the generator from your calling function. So you don't see that too much in like you're using it as an iterator. But basically you can then, when you've said like dot next and you've gotten your value back, you can call next with like, this is what I want to have be placed as that value in the function. And so it's a little blurry, but basically on the left side here, when you call example, you call it to kind of initialize the generator, and then you advance it by dot next. And so when you call dot next, it advances to the yield 1, which is on line 2. The value for that should be 1, which is cool. But then when you call next again, you can pass a value into the next function, which will then replace this yield 1 expression with whatever you pass into next. So you're kind of like placing something where that yield used to be, which is kind of like the magic sauce for all of this to happen. It'll also then advance to yield 2 and give you that value back. But then once you start it again, basically first and second will be first and second that you've then kind of injected into that function. This right-hand terminal is basically just the interface you get back from calling next. You advance it through calling next, and you get a value and a done, which kind of matches the iterator pattern in JavaScript. So you can use this in like a for of loop. Yeah, so basically our recipe is start the generator, advance the generator to the first yield by calling next. If this is an async function, our await is basically going to be a yield. And so the value of like an await fetch will be a promise. And so you return that, or you receive that from the generator. And then basically you hook up that promises.then to restart the generator when it's resolved, whenever that happens. And so that's how you kind of get around like not blocking when you're inside the function, you don't know that you're really being stopped and then like put back on. And so basically when you restart it, you then pass in the resolved. Since the then function from that promise is kind of restarting it, you have the actual value from that promise. And you can just kind of like place it back into the function as if like nothing ever happened. And just kind of like the kind of similarities of the syntax are similar. But basically, like a sort of async function, just as a generator function, and instead of a wait, you're just yielding the promise from this fetch call. And so our like kind of imaginary runner function will then return a promise like an async function will, and we can use that result. The next slide is a lot of code, but this is all it is. Like, and basically the interface is you give it a generator function, which in that case was like that Pokemon API function, and then kind of the list of arguments to apply to it. On line 3, iterator is just kind of the initialized kind of generator instance, and then you immediately return this promise, which then when it resolves, you know, next tick or immediately or whatever, that will basically, what do you call it? Kind of advance the iterator to the first yield, which is happening on line 8, and then pass in the value that is given to next. I might actually have a bug in here. But basically the first next call would be undefined. Oh yeah, so I should have put that in there. But basically that'll advance it to that. And then in this point next is the like promise result from that fetch call. You then return from that then basically a call to, oh no, this is all right. Trip myself out a little bit. You then like call that handle result with next, and then basically since that's coming from a generator, it'll be a object of value and done. If you're at the end of the generator, you will know that next.done is true, and then that promise resolve value will be the actual value returned from that function. If it's not done, you want to then kind of convert that next value into a promise using promise resolve. So basically, if it's a fetch call, you know, it's already a promise, totally fine. If it's like a random non-promise value, promise resolve kind of converts that to kind of flatten everything. And then once that is done, basically you're then jump starting like the generator once that value returned is done. And so kind of the comments are basically handle next. We'll restart it once your returned or your yielded promise is resolved. Handle result is basically for scheduling like handle next to run. The whole try catch thing also is supported with this version, just because if you call iterator.throw, that'll actually throw the error in the context of the generator, which is why try catch works. And then if the dot then is basically if you handle it or not, you can like return that. So that's kind of a lot to kind of like take in all at once. But it's also like 23 lines, so like pretty cool. This is all mostly from a Kyle Simpson book, the You Don't Know JS, Async and Performance. This book kind of like, I feel like this is probably the most important JavaScript book I've ever read. Just in terms of they kind of go through the history of everything and like from callbacks to what's bad about them, promises and what's good about them. This entire talk is basically a chapter in this book too. But it was kind of like, I don't know, opened a lot of doors, I feel like, for just kind of understanding and not just kind of fearing the async parts of JavaScript. So I definitely recommend it. This is like another bad joke, but so here's two functions. Okay, and so they're the same function. This is kind of a bad office joke, but it's like they're the same picture. Anyways, questions?
So how does performance compare between async and await and then using generators and yield?
I would need to do some benchmarks. I was reading, the first time I gave this talk was when Node 12 was coming out. And kind of the point I was trying to make with this was like for people who were thinking, oh, if I handwrite promises, it'll like be better than using async await code. In that vein though, like I know there's a V8 blog that kind of shows how what is it? They made some like, I hate to,
Microtask queue, right?
oh yeah, where they get rid of like kind of a throwaway promise that's like in the implementation only. But when they were benchmarking like promise code versus async await code, I think like from their benchmarks, it seemed like just pure async await code actually performed a little bit better because the implementation can make some kind of shortcuts, I guess. I honestly have not actually benchmarked the runner function.
No worries.
I'm sure there's like optimizations you can make though, just because you end up like having like a giant promise chain that probably like can't be garbage collected for a long time until like everything is done. But yeah, good question. But yeah.
Weird bit of kind of JavaScript history trivia. Apparently, the V8 team at Google wanted to introduce async await first, but TC39 was like, no, you need the primitives of promises, and you kind of have to let that go through. So like, there was some foresight into like, we want this simpler call structure, but it had to go through kind of multiple stages of approval and evolution through TC39 to get to what we have today.
Oh wow.
Yeah.
Huh, if that was when promises were happening, was that like
Right.
a long time ago?
Yeah, and like 10-ish years ago, right? Like early days in promises, they were actually internally like, we should go with the asyncwait call structure, and they didn't. I was a long time promises hater.
Oh, nice. Nice. Like old school Node.
Old school Node callbacks.
Nice.
I mean, I still like callbacks. I would use them if more people were cool with it.
Right?
Yeah. But you're like, oh man, just pass it a callback, and people lose their minds.
Yeah.
Well, I had a question, Chris. Also, thanks for speaking really last minute. I think I just GitHub issued you yesterday, and you're like, oh yeah, I can do it today. So.
Oh yeah, so I like 11.
For that.
I was like, I can probably do this.
Yeah. So yeah, I guess my question is if so my work, they work on like a monolithic application, and now they're like, oh yeah, async await is pretty cool, and I haven't asked them like what their migration strategy is, going from callbacks to async await. I know I've looked through the code base, I see callbackify, I see all these other types of things during the transition, but what do you usually tell people when they're migrating from callbacks to async await?
Oh, that's interesting. Like I know it what was it? There was kind of like a time at PayPal where like some kind of like internal things were being kind of converted, but that was between like promises and async await, which was basically like a non-issue just because like you almost like don't even know the difference like from like if a library uses it or not, like who knows. I honestly haven't used callbacks too much in my code. I started an internship at this kind of repair company in Slow, and they had just started, someone was like very gung-ho about promises when I started, and they like had ripped out all the callback code. And this is in like 2014 too. So I like didn't even have a chance, I feel like. But it's callbackify, like you can just like, it's almost like promisify, but like the opposite. You like hook up the callback into like the promise result, or the then call like a promise function.
Yeah, that's kind of like going in the opposite direction, because I feel like there's some cases where they don't want to change that like that function, so then they turn it they use callbackify, and in some other places I see promisify as well. So yeah, I was just curious on that.
Oh yeah. So I haven't seen that too much, but that seems like a huge jump though, like to go from callbacks to asyncwait. But good luck.
Yeah, the hardest thing for me there was actually, getting comfortable with throwing. Like, for 5-10 years, like a really long time, my mindset was like never throw, and now it's with asyncwait, it's an appropriate and acceptable thing. I saw so many errors with folks coming from other languages and being like, I should throw here, and in Node, that basically just kicking off an uncaught exception that I'd grown really anti throwing anything just because it broke the platform. But with asyncwait, it's part of the model, JavaScript model, the language model.
Yeah, seeing try catch still kind of makes me question, like, is that
right? What are you doing?
I don't know if that'll work. Yeah, cool. Well, feel free to say hello on the internet. I'm Copperwall at everything. It's just my first initial and my last name. And thanks a bunch.
Thanks, Chris.
Let's see.
Yeah, it's weird. You don't get the rounds. You never hear anybody clap on these.
Right,
things.
right. You need like low key somehow audience, vibes. You don't want folks like me or you, Chris, other Chris, being loud and actually commenting. But we kind of want, yay, woo.
We actually need a 90s sitcom style soundboard.
Totally.
Just somebody sitting there pushing buttons at the right time.
We're on it for next month.
Well, this is
awesome.
the part of the evening where we would normally do our 30 seconds of fame. So we'll still do that.
Should we raise hands to get on 30 seconds?
Yeah. Use the old Zoom hand raising feature. I've never actually used it myself, but I know it exists. But yeah, so 30 seconds of fame. If you've got a job that you are looking to fill, if you're looking for work, if you have a project that you're working on, if you're tinkering on some open source thingamajig and you want somebody to come help you out, now's your chance. It's open, it's free, it doesn't cost you a dime. You can just stick your hand up and be like, hey, I want some help. Anybody?
As the host, I actually don't think I'm. Fernando. Let Fernando go first. I actually don't have a hand raising thing as a host, oddly enough. So I'll raise my hand too. But let's let Fernando go first.
Cool. Thank you. Thank you for the meetup and organizing things to keep us entertained during this whole thing. So 2 announcements. As some of you know, one of the organizers of Node School San Francisco, we're looking to do some virtual focus sessions. So if you have some stuff that you want to share with our attendees and community members, let us know. Anything from like Node, web development, client-side JavaScript, or whatever. So let us know. We're still organizing, but we're looking to start hosting maybe 2 weeks from now, and like every Saturday afternoon for a couple hours. Just reach out to Thomas or myself on Twitter, and we'll make it happen. Announcement number 2. So 2 employers ago, I used to be at Groupon, and I don't know if you heard, but like a lot of my former talented coworkers got laid off yesterday. So if you, like a bunch of people like half of the company. So if you have any like leads or your company is hiring, let me know. I'll put you in touch with them. They're super talented folks. A lot of them work with Node. Like Rupam was super passionate about Node. Like all of their web layer was built on Node. So I'll be happy to like do referrals and put you in touch with them. Thank you.
Cool. Should I go, Chris?
Yeah. Take it away, Disha.
In this time of uncertainty, I've been doing some volunteering, and I'm working with a group called FOSS Responders. So, you know, FOSS Responders is sort of rallying a bunch of folks that you know, are from various organizations, OSPOs, the open source offices, all coming together to help open source developers, individuals, and also, you know, so much of the open source ecosystem is supported by events, and you know, events are just getting slammed. So folks, you know, have massive budgets already allocated to you know, paying for a venue and you know, all the down payments and stuff like that, and are just, you know, left holding the bag. So FOSS Responders has you know, gotten together, and we're you know, able to give to individuals in the thousands of dollars range. We're organizing an event on the 1st of May that will be you know, gathering you know, corporations and you know, able to target, you know, larger ticket things. So you know, both you know, on you know, the open source side, if you need help or your event is underwater and you need support, you know, please you know, feel free to reach out to FOSS Responders and apply for a grant. And you know, if you're gainfully employed and you know, haven't found the right vehicle to you know, support you know, folks that are you know, less privileged than you, you know, consider you know, donating you know, $50 or something like that to FOSS Responders. Good group of folks. You can do it relatively easily through Open Collective. So you know, fossresponder.com. Check it out. Thank you.
Cool. Is this going to be
Rich,
the earliest we've ever wrapped up? Yeah, what's going on, Rich? What does Rich have to say?
I landed some PRs, so I did my duty to make this officially SFNode. I can't think of anything. You know, yeah.
Thank you, Rich.
I can't find the hand thing, but I'm like raising my hand.
That works.
Really, Chris?
Cool. Okay, so my company TruePill is hiring right now. Turns out people still want medication by mail when there's a global pandemic. And so I think I can post a link in the meetup. And then also, secondly, if anyone has any like open source projects they want help on, or like want a helping hand on, I really like just kind of contributing where I can. Sometimes I like have trouble finding things, but totally feel free to like message me on Twitter or anything, or whatever works. But thanks.
Awesome. So Chris, drop a link in Zoom, and then I will, or you can actually punch it to YouTube if you're logged on. Otherwise, I'm happy to pick it up and make sure it goes out to the live stream as well. because this will only get to folks that are kind of in the house. I want to make sure that message gets out to everybody.
Let's see.
Anybody else that?
Yeah, so definitely want to thank everyone for bearing with us. Yeah, I know JSLA had a beautiful setup that was organized with transitions. None of us have any of that experience here, so I definitely want to thank everyone for joining in on the Zoom. We actually had about a dozen folks on the live stream all evening, so shout out to them as well. We are definitely going to continue to improve the process if we need to do the same digital event next month as well, which seems kind of likely. So thanks again for everyone definitely on the bearing with us on the technology side.
Thanks for getting it together.
Yeah, it's good to see everybody. That was nice. This is nice.
Sorry for the missing pizza. You had to bring your own beer.
BYO.
Yeah. Bring your own everything. Bring your own background.
Right. I'll try harder next month with a good virtual background. I'm very happy with my real life background. So. Ooh, Rich is getting disco over there.
Yeah, I don't know what's going on with that. What the hell?
Oh my gosh.
Did Rich figure out some crazy weird thing to do to Zoom and well, it's like almost invert. It's weird. Yeah, I don't know. I don't get it.
If your green screen if the green screen thing fails, it gives you an option to select the color that you should fill in. So if you have like a solid shirt, it can just be your shirt is the background. It's pretty cool.
Nice.
But I'm wearing like a pin, a checkered shirt, it doesn't. Well, yeah, there you go. It works a little bit there.
Yeah. Okay, now that's useful information.
But before I was doing on the windows, which when the light was coming in, it wasn't the same color as the walls, so it would just be through the windows. That was when Chris thought I was in a spaceship. But yeah, right now it's a little harder to find a color that one. I mean, I guess I could try this one. You can see it outside now, and as you move around it. So there you go. Now this meetup was totally worth it, right?
It's all we got, backgrounds on Zoom.
I mean,
our portal into life, the real world.
I mean,
thanks for the talks, guys.
Yeah, thanks for showing up, man. We appreciate it. We really do. Like, even though we're not in person, face to face, like we normally are, nobody else is either, and it's kind of cool that we're still managing to do something. And yeah, so thanks for taking the time.
Yeah, I'm gonna drop off, but thanks everyone.
Yeah, I think on that note.
Thanks, Chris. Thanks, Rich. We are 6 feet apart.
Yeah, the comment, we're all at least 6 feet apart. That's fantastic. That's great. On that note, I think that's been SFNode's edition for April. We'll be back in May in some form or another. Probably here.
Probably
here.
Yeah. But
maybe a little bit fancier. Probably not.
Maybe. Let's be realistic.
I'm gonna try.
All right.
This is good.
Thank you.
We got to see on the live stream a few of our faces, and I thought that was nice. So we'll have a look at the. I liked the presenter view that JSLA did, but we also got to see people view, and that's good.
Yeah. But that's gonna be it for me, folks. Everybody have a great day, and enjoy your life.
Yeah, and the live stream will be saved. We'll also take a look at the Zoom meeting and see if it's worth chopping that up and posting to YouTube as well. But we'll probably just reference the live stream that we had.
Cool.
Awesome. Thanks, everybody. We'll shut down the stream. Bye.
All right. Bye, everyone. Thank you.
Thanks, Thomas. Thanks, Chris. Thanks, everybody.
Peace.